So question 7. Question 7.1, we are asked to find the derivative of f of x using first principle given the f of x of 4 minus 7x, right? So to find f of x plus h, we will substitute a 4 minus 7, where there's x we put x plus h, right? And yeah, you can just leave it like this for now. We'll solve it later. Later is now. So we have f prime of x being equals to the limit when h approaches 0 of f of x plus h minus f of x divided by h, right? So the limit when h approaches 0, remember I said f of x plus h is 4 minus 7 into, so it's 4 minus 7 into x plus h, and then let's just put this in brackets minus our f of x is 4 minus 7x, so it's 4 minus 7x like that, divided by h. So the limit when h approaches 0, so it's going to be 4 minus, so the 7 will multiply everything that is inside, so it's 7x minus 7h minus, so this minus will multiply everything that is inside here, so you have minus 4x, minus 4 plus 7x divided by h. So what's going to happen is like terms will subtract each other, and then we remain with 7h, is it negative? So it's the limit, by the way, so it's going to be equals to the limit when h approaches 0. We have what's this? We have 7 minus 7 h over h, right? The h goes away, so we remain with minus 7. So that would be the answer, the derivative of f of x. You always have to check whether your answer is correct by writing your f of x, which is equals to 4 minus 7x, right? And the derivative of this is definitely, it's a 0 at minus 7, so which is equals to minus 7. So you know that your answer is actually correct. Always check, please. So we're done with this limit here. Now we're gonna go to 7.2. We're asked to find the derivative of this, so let me just remove this. So to find the derivative of this, what you can do is we'll change how we write this here. We know it's the root is a square root, rather there's 2 there, so meaning that it will change how we write. So it's going to be y is equals to 4x to the power of 8 plus x to the power of 3 into 1 over 2, right? So this is 3, and then y is equals to 4x to the power of 8 plus 3, plus x to the power of 3 over 2. So now we can find the derivative of y with respect to x. So we're going to drop the 8, let me do this, drop the 8 into 4x to the power of 8 minus 1, close brackets, plus drop the 3 over 2 into x to the power of 3 over 2 minus 1, and the d of y over d of x is equals to 8 times 4, which should give us 32. It's going to be x to the power of 7 and plus the 3, right? And you subtract at the top, you should get 1 over 2, so it's going to be x to the power of 1 over 2 over 2, right? So the final answer would be d of y, by the way, d of y over d of x is equals to 32 x to the power of 7 plus 3 over 2 x to the power of 1 over 2. So this is the final answer, but if you don't want to write it like this, you can just say dy over dx equals to 32 2x to the power of 7 plus 3. So you put it on square root because this is a 2 at the bottom, divided by not the entire thing, but just this one divided by 2, right? So this is the final answer of this problem here. Let's do 7.3. So 7.3, we are given y is equals to ax squared plus a, and we're asked to find the derivative with respect to x. Dy with respect to x, so you're deriving y with respect to x. So you're having your y is equals to ax squared plus a, and to find dy over dx, so you're deriving this x squared, which would be 2ax plus 0, right, because this is a constant. So dy over dx is equals to 2ax. So this is the final answer for this one here. So now let's do another one. So 7.3.2, we are asked to derive, let me just write the equation. So it's y is equals to ax squared plus a, right? So deriving y with respect to a. So when you derive this a here, this, it will remain. So it's going to be x squared, and then deriving a, it's going to be plus 1, right? So this would be our final answer for this problem here. So we're just going to go to the last question, this one here, and what we are given and asked to do here. So we are given, so 7.4, the curve of the equation passes through this point of a. Determine the equation of the line perpendicular to the tangent to the curve at a, right? So we're having our equation y is equals to x plus 12 over x, and we are told that it passes through point a of 2 and b. So let's find b since it passes through it. So we're just going to substitute. Where we see x, we put 2. Where we see y, we put b. So this is going to be b is equals to 2 plus 12 over 2 equals to 2 plus 6, which is equals to 8. So b is equals to 8. So this means is our a would be 2 and 8, like that, right? And our equation of y is equals to x plus 12 over x now. So determine the equation of the line perpendicular to the tangent to the curve. So the tangent to the curve, so we have the curve being equals to x plus 12 over x, right? So let's find the derivative of this curve. Why are we finding the derivative of this curve? Is because they're talking of a tangent, and the tangent is perpendicular to this line. So we just want to find the gradient of the tangent first, and then we'll sort out everything. Or we can find by deriving here, we can substitute, right? Substitute these points here, all right? So let's just first derive this. So d of y over d of x, but before we derive, let's take this x at the top. So it's going to be y is equals to x plus 12 x to the power of minus 1. So d of y over d of x is equals to 1 plus, so we drop the 1, so it's going to be 12 into minus 1 x to the power of minus 1, like that. So d of y over d of x is equals to 1 minus 12 x to the power of minus 2, like that. So that is the derivative, right, of this expression here. And what we need to note is that this derivative, the tangent, the x value of the tangent is the point of a, actually. So let me just write it nicely. So d of y over d of x is equals to 1 minus 12x to the power of minus 2. But we need to remember that it passes through this point of 2 and 8. We found b to be 8. So we're just going to substitute this x value of equals to 2 and find the actual gradient of this tangent. 1 minus 12 into 2 like that minus 2 should get your gradient to be minus 2 if you punch in your calculator. So this is dy over dx, right? So it's the gradient of the tangent, and you're told that this line is perpendicular to the tangent, right? So m of t is equals to minus 2. That you should note. But we are told that m of t is perpendicular. So if it's perpendicular, we multiply the gradients. It must be equals to -1, right? So the gradient of the tangent is minus 2. We don't know the gradient of the line that is perpendicular to the tangent, and then it's equals to -1. So we divide by -2, divide by -2 both sides. So m of the line is equals to 1 over 2, right? So now we know the gradient of this line here, right? Gradient of the line equals to 1 over 2 there. And now, because we are asked to determine the equation of this line, right? So we also know that this line passes through point A, right? So our A being 2 and 8, right? So we have y is equals to mx plus c. So this is the equation of the line. So y of the line is equals to the gradient of 1 over 2x plus c. So substitute these 2 points here of 8 and 2. It's 8 is equals to 1 over 2 into 2 plus c. So this 2 goes away. We have 8 is equals to 1 plus c. 1 goes to the other side. We have c being equals to 8 minus 1. C is equals to 7. So the equation of the line is equals to 1 over 2x plus 7. So this is 7. So yeah, this is the equation of this line here. Done with this question, off to the next. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comment section below. Don't forget to subscribe to the channel for more videos.